Okay, we're going to introduce chapter 4. Now, a lot of chapter 4, we've kind of already introduced a little bit because we went through and we did a bunch of tool demonstrations at the very beginning. Remember, we were talking about safety. And so this is going to be a lot of, there's going to be a lot of information overlap a little bit. But also one of the things I really hope to do is kind of get a little bit more deeper into how things are used and different tooling that can be associated with them, and just some of the differences between the different machine options that are out there on the market. And so we're going to be talking about portable power tools, okay? And so in the chapters, they kind of classify things in kind of 5 or 6 different areas. You have your saws, planers, routers, drills, sanders, and fastening tools, okay? So we're going to get into each of these. Okay, so first thing is your circular cutting saws, okay? And when you go out on the job site, there's not a ton of saws out there. I mean, yeah, you've got your reciprocating saw, you've got your circular saw, and those are kind of the main ones. I mean, there's some specialty ones. Say that again. Miter saw, yeah. A lot of the contractors those are light enough that you can kind of bring on site too. Yeah, so that's good too. But yeah, circular saws, because there's not a lot of accessibility, and they get used in a lot of different ways, okay? And so they're a really valuable thing to kind of learn, but they're also, incorporate some issues as far as danger in that way, because it's a circular saw, right? And so you've got those 2 different motions. Remember when we talked about how you've got one vector angle of force coming up against the platform, but then you also have one pushing forward. And so you got to be strong with the saw, right? And you have to understand that you can't bind the blade, because that's going to only exacerbate the kickback. But generally, the purpose of a circular saw is for straight line ripping, but you can, I mean, obviously you're not going to be cutting curves with a circular saw, but you can do things like you can cut in and create a bunch of curves, and you can chip things out with a chisel. So again, it's straight line ripping, but you can use it for a lot of different purposes that way, okay? You can cut the tails off of the rafters. You can cut out a bird's mouth. You can plunge down into a sheet of plywood and cut out a square. There's just a lot of different things that you can do with them. Generally, your circular saws, your portable ones like this one here, are going to take a blade that looks like this, okay? And there's different types of blades. So this is a 60-tooth blade. This would be more for if like you're cutting plywood, right? Or cutting something that needs to have a better looking finish, right? Cross cutting, that sort of thing. It's got small teeth, small gullets. It's got carbide teeth, so it'll stay sharp for longer. And so that's kind of what these little blades are for. But in situations where you're doing a lot of long ripping cuts, you might want to use a saw blade that has a little bit deeper throats or gullets, so that it can pull out those chips a lot more efficiently that way, okay? And so just understand that they have different types of blades designed for doing different things, cross-cutting or ripping, okay? And generally that has to do with tooth profile. You also you can buy different diameters. So there are different types of saws. So don't get those confused with like a table saw blade, which you can buy in a 10-inch diameter. And then the miter saws are generally 12. You can buy miter saws in that have different diameter saw blades. Here's a 12-inch saw blade. Generally, the ones that they sell for the miter saws will have a different rake angle, because they're generally used for cross cutting, and a flatter rake angle performs a little bit better than do you guys understand what rake angle is? Basically the angle of the tooth profile. And so just pay attention to that. But yeah, so you've got different diameters. You also have different arbor hole sizes. Some table saws will take a larger size. Here's your cross-cutting or your miter saw that has a much larger arbor hole size. So you have to kind of pay attention to that. Some of these blades are pretty fancy though. For example, this is one that I bought here from I think I bought it from Lowe's or Home Depot here this last year when we were doing that locker project for the lacrosse team. But there's a lot of technology that they're putting in these blades nowadays. So you not only do you have the carbide teeth, but you also have these kerfs that kind of come in. I have a saw blade on my saw at home, my table saw. Whenever I turn it on, it resonates and rings, and it's really loud and obnoxious. It's because I have a cheap blade on it. Okay, you buy some of these blades that have these laser cut squiggly lines in there, and that's going to help dampen those blades so they don't ring that way. And when it gets hot and it gets because you're using it hard, when it expands, it's going to be less apt to warp. Okay, some saw blades, the really good ones, it seems like the ones that last a long time, the ones that you can resharpen over and over, have some thickness to them. I mean, you can tell a quality saw blade from a cheap one because there's some mass to it. Okay, and so if you do, if you buy quality saw blades, they will last a long time, and you can send them in to get resharpened over and over again. Okay, I'm talking about the high quality carbide blades. All right, the company I use to resharpen saw blades is Acme Tools up in Des Moines, and they have one of these fancy CNC diamond wheel grinding machines that they can go through, and they resharpen those blades, and they're sharper than they were the day I bought them. I mean, they do a really good job. Here is an example of another circular saw blade. This would be used on kind of a saw like this. A lot of these little saw blades will have, I don't know if you've ever noticed, but they have, I suppose they're laser cut lines where it actually has a diamond pattern. So oftentimes these circular saw blades they can be used. There's two different types of circular saws. A lot of the worm drive saws will have kind of a diamond arbor instead of a round arbor like this, okay, because they are a little bit heavier duty. And so you can usually punch that out of the middle. It's just taking a screwdriver and a chisel, and you can punch that out and remove that to use those blades for that particular type of arbor. Okay, but this is a plywood blade. You can tell because it has really small teeth, and it is designed for our panel saw. We use this on our panel saw because we cut a lot of plywood, and we design. I mean, obviously, you don't want to have a lot of chip out, and so when we were running those lockers, we use a saw blade like that in order to get as clean of a cut as we can. Okay, so that's some general information about saw blades that way. As you use them, you want to keep your eyes out for stuff that looks like this. I don't know if you can see this, but there's a lot of gumming. Wood has a lot of pitch, and when it gets hot, it gums up on the blades, and so you do have to remove that. Here just recently on Rockler, I ordered this. It was like a tub, and it had come with a chemical, and so we're going to try it. We're going to soak this in this. It's kind of a pitch removing solvent. We're going to see if we can clean these up and get another use out of them before I send them in for resharpening. But eventually, though, the blades do wear out, and the sharpener will sharpen it one last time, and he'll put on there using an engraving tool, NWS, not worth sharpening. Basically meaning, use it this last time, don't send it back, because it's not quite running true anymore. Okay, and so there's that. And the other thing too is, if you're really abusing these things, eventually these little carbide teeth will come loose and they'll break off. And if you get too many of those, I mean, one or two is not a big deal, but if you get too many of them, then that's usually another reason why they put on there not worth sharpening that way. It's best to just go back. Just to give you an idea, a new blade, a good one, will be around $60, $60, $70. A 10-inch blade, I'm talking. To get it resharpened, $40, $50. So, I mean, it's not like you're getting a substantial savings. but you're at least getting some more life out of what you got for a little bit less money. Okay, so you've got different types of blades, different sizes. You know, when you're looking at portable saws like this, you've got the choice between battery and or corded. All right, and for doing circular sawing, you know, usually if I'm cutting an 8-foot long piece of plywood, you know, that's a long cut. All right, and it's going to take a pretty substantial battery. You wouldn't ever want to use a battery like this on a saw like this, right? Because it's only a 1.5 amp hour. Okay, so these batteries are rated by voltage and by amp hours. And here's an example of, this is a 20-volt max, and this one has, it looks like a 5 amp hour, but I thought that it would label it on here. Oh, this is a 4 amp hour. A lot of them are 5 now. The more amp hours you can, the longer it can power your saw, and you're going to want to have that if you're doing any substantial circular sawing with a battery powered machine that way. The other thing I really like on these batteries, and I don't know that I have any examples, is they have this little push button thing, so you can actually push button and see how much charge they have left, and that's a nice feature that way. We still have a lot of those old the old battery packs. The lithium ions are pretty awesome and hard to beat. I need to buy some of those conversions so I can use the new batteries with the old technology, the old connectors that way. But you've got your Sidewinder, right? This is your direct drive. So they basically have the motor, and then you have your blade attached directly to the motor. But there's also what you call the worm drive, and you can kind of see how that works right there. So the motor is at a 90-degree angle from the arbor that's driving the saw. And so those, again, are going to have this little gearbox right here with a worm gear, and that's going to be filled with oil. And so you get a lot more power, and you get a lot more longevity. They're going to last a lot longer. Okay, they're for really heavy-duty applications that way. All right. So, you know, my brother, who's a framer, he had a worm saw, and he used the crap out of it, and it lasted him. Gosh, he had the same saw ever, you know, from beginning to end, and he worked in that industry for about, gosh, 10, 15 years. I mean, that's about all his body could take, but he ended up having back problems. Another reason why you're here, right? That's hard work. You can use a track, or you can set up a fence. So there are saws that they're called track saws, and they come with a track. And if you want to get really long straight cuts on sheets of plywood and things like that, you know, stuff that's so big and awkward that you can't really do it on a table saw, having a track saw is really nice. But oftentimes what I'll do is I'll just take a board and I'll clamp it right where I want it, and then as long as you keep the edge of your base run up tight along that fence, you can cut perfectly straight lines. Okay. Chip out is something that you need to think about before you cut into that. I guess last time I priced out plywood was about $110 for a sheet of 3/4 inch birch plywood. So before you cut into that, better make sure that the good face is facing down, so that as that saw cuts up, it chips out on the back side, or the poorer grade of the veneer, rather than the nicer grade. Okay, so that's what I'm talking about as far as chip out. Saw horses using correctly. Here you can see the correct way to use the saw horses. You're cutting off the end so that the end of the board, as it gets so thin that it's weak, it falls, it's not going to bind the blade. As opposed to if you were to try to cut it between the saw horses, what's going to happen? Bam, it's going to drop, it's going to pinch the blade, and it's going to kick your saw back, and that's no bueno. Okay. The other thing too is oftentimes doesn't get done, but you really should, is just making sure that you're setting the blades. You don't have a ton of blade exposed. You can just quick flip that and then adjust your blade height, or how far deep your blade projects through past the base and then go ahead and cut that. Two reasons. One, I think it does improve the surface finish of your cut, but then also, more importantly, just not having as much blade exposed, it's going to prevent you from cutting through your cord or, having other issues that way. Okay, so here you can see the proper blade depth, about 1/4 inch to 1/2 inch below the board that way. Okay, so that's kind of the circular saw. Do you guys have any questions or comments about the circular saws that way? It's a workhorse on the job site. And we use it in the wood lab too. I mean, when we have a large piece of wood that we need to make a cut on, sometimes this is the best way to do it. It's just large and awkward. Or if we need to, for example, I guess here's a good example. Had some students in the DIT group working on making a little mini putt hole for the William Penn golf mini putt, their big fundraiser. Anyway, they're building a windmill and they need to have like 8-inch by, so the base is made out of several trapezoids. In other words, they're not rectangles, right? So they have to cut an angle, and they're large enough that you can't do it on a miter saw. And so what's the best way to do that? They need to be able to get very straight lines, and so that they get nice joints going up that base. And so I've recommended to them to lay it out and to use a circular saw that way. So that'd be a great way to do that. Okay, next saw is what we call a jigsaw, or a lot of people will call them a saber saw. But this is kind of what it looks like. You have a saw, it has a base. When you pull the trigger, you've got a reciprocating blade. The blade is only about, at its shortest point, about 1 inch long. Okay, so you can't really cut a really thick material. It is true they have some different types of blades that you can buy for these that may be a little bit longer, but generally, you're going to be cutting relatively thin material. Okay, but notice the blade width. All right, what's the purpose of this saw? For cutting curves. Okay, so is it the best saw to cut curves with? No, not necessarily. I mean, best, that's kind of a relative term, right? It really is determined by personal preference. I know for me, I would rather use a bandsaw, but I may not have that. Or maybe the circle is so big that the bandsaw doesn't give me the clearance to do it, or it's really awkward to try and turn on a bandsaw table. And so in that case, this would be the best saw to use for that. It's nice because you can lay out your sheet, right, and then just kind of work the saw into it, and because it has a narrow blade, you can cut really tight radiuses. And for radiuses that are even tighter than what this blade would allow, you can do things like nibble cutting and cutting relief cuts and doing things like that to try and to do. So there's a little bit of pre-planning that's required that way. This particular saw is nice because it has kind of some different stroke options, so it actually makes the blade a little bit more aggressive by adjusting that. And the nicest thing I like about this saw is this right here. Look at this. Change the blade, bam. And so I'm kind of sold on this DeWalt. And you know what? Yeah, I think it probably does. Well, this does something. I've never used it. It looks like, yeah, there we go. Of course, now I'll never be able to get it back. Back square. Actually, I think it has, there it locks. Yeah, isn't that nice? Man, those tool makers, they're thinkers. They got it figured out. Isn't that the value of marketing, though? You've got people that are part of your marketing. They give away all these tools. Use them. Give us your reviews. Give us your feedback. What do you like about it? What don't you like about it? What do you wish you had? And they'll figure out how to make it better. And then they've got their different lines. So Black & Decker has their DeWalt line, and then they have Black & Decker, which is your more economical. It's all under the same umbrella, but it's all the same company. They got their different brand names, trying to hit different markets that way. They're smart. Anyway, The other thing too, sometimes you'll go to these auctions and you'll pick up a cheap, jigsaw, and you just got to be careful because the old ones use this different style of tooth or bit attachment. So the newer ones, they kind of look like this, and the old ones had kind of a pin. They were much more difficult to put in. But they also they sell replacements that are kind of dual. They can be either one. So anyway, and you've got, this would be a metal cutting blade. You can buy blades that are designed for different materials. So this is a wood cutting blade. They've got a fast wood, so a little bit more aggressive, and they've even got plastic. I think I've even seen some that have diamond coated, designed for cutting, ceramics. Yeah. So, huh? Yeah, they make the whole saws sometimes. Yeah. Yep. And you can buy the diamond blades. If you got straight cuts, I'd use a circular saw with a diamond blade, or if you've got one of those wet saws for cutting ceramics. But yeah, sometimes you'll maybe need to do. I know if I've put in a couple tub surrounds, and I've used like the whole saws that have the diamond. Those are good too. So, but anyway, that's kind of the jigsaw. There's a tool, specialized tool, called an oscillating tool. And so I've got a couple of examples of those. And the nice thing about these tools is all you need is an Allen wrench to pull this off, and you can take and put different types of attachments on them. And so this is an example of a sanding attachment. So they can be used for sanding. But this is probably the one I use the most. This is a little saw blade. All right. And they've got different shapes. Here's a different one. So depending on what you're sawing, you can just attach that to the bottom. And what do I use this for? Well, the main thing I use this for is when I'm installing flooring and you need to shorten up your door casing, just going in there and just kind of shortening that up. It's pretty phenomenal that way.
Isn't that kind of just like vibrate or something?
Yeah. Yeah, it just kind of goes, just oscillates real short. And that's the reason why it doesn't remove material very well. But boy, it burns right through it. I find that when the teeth get dull, obviously it doesn't cut as well, but you can still remove material and it just kind of burn right through the material. It works. And so you just can't, you got to be careful not to hit any nails because those little blades, they're not carbide. Yeah. Yeah, the challenge is when you're trying to cut so close to the floor, you just don't have a lot of clearance. And so that is really the best tool I've found to do that. There is a picture of it right there. Yeah. So that's called an oscillating tool, multi-tool. All right, miter saws. Okay, miter saws are used predominantly for cross-cutting and for cutting bevels and miters. Does everybody understand what miter? So miter is if you just take the table and you adjust it and you cut it at a 45-degree angle. But then a bevel is if you take the whole head of the saw and you tilt it and then you cut at a 45-degree angle. And if you do it both at the same time, so a miter and a bevel, that's called a compound cut or a compound angle. You got two different. And so, yeah, right? So like this is it looks like a, I don't know, maybe it's hard to tell because by looking at this picture, it's hard to see what angle it is. But so you've got three different types of these, right? So you have your chop saw, which only allows you to chop down. Generally, you don't see a lot of those around the woodworking area. Those are generally you find in like the metalworking area where you're just chopping off rebar and things like that. You've also got what you call a miter saw, which that means you've got the option to swivel the table. And then you have your compound miter saw, which means you can bevel it and swivel the table. And then you also have the sliding option. And the sliding option is where you start to pay the big money. but it's nice because, you know, a 10-inch or a 12-inch blade on a non-sliding saw, I think your maximum width of board that you can cut is 8. I was gonna say 6 or 8. Yeah, I think it's 8. So having that sliding action will allow you to cut up to 12 inches in a lot of them. I think they're a little bit different. Now that radial arm saw we've got in the other room, it'll cut 24. So that's really nice. So oftentimes I use these for trim work, and oftentimes when you're doing trim work, it's a lot of trial and error. I mean, you can measure it close, but you know, it's always easier to take a little more off than you can't really stretch out a board, right? And so that was the big joke, right? When I was going through high school, well, just get out the board stretcher, you know. Took me a while to figure out that he was pulling my leg. But anyway, one of the tricks that I like to use is when I am sawing a board or a piece of trim, is I'll bring that trim up and I'll push it up tight against the saw blade, the inside of the saw blade like this. And what that does is that takes off the thickness of the offset between the carbide teeth and the inside of the body, which is about a 64th of an inch. It's not very much, but oftentimes if I'm just trying to get it to fit just perfect, I'll use that as kind of a means of measuring and cutting off just a smidge. And so that's kind of a nice little trick that way. Okay. And then if you need to take off an 1/8 inch, that's about the width of the blade. If you want to take off a 1/16 of an inch, that's half a width of the blade. And so the blade is a great reference for removing material without necessarily laying out on the board, because oftentimes you're just needed to take off a little bit and you can't really lay that out very well anyway. So we've talked about the different types of blades: high-speed steel, carbide. You've got your ripping. This is what you call a combination rip and crosscut. And so these are kind of nice. All right, portable hand planers. I brought mine. This is, whoa. Yeah. This is not a tool that I use a lot, but there are times when I do. How it works is you have your sole, you have a front feed or front part and a back part of the sole. The back part is fixed. The front part you can adjust by rotating this. And so if I wanted to make a really deep cut, I could adjust it one way, and they've got little, so if I want to make a 1/64th of a cut, basically what that does is that moves this front sole 1/64th of an inch up, so that as you're feeding this into the board, there's a cutter head that rotates and it'll take off a 64th on the front end, and then it basically slides out the back. Okay. And so these are really good. One thing I do use this for is like if I'm on the job site and I need to basically put a taper into a board, as I'll take it right here and I'll you know, adjust it to a 1/16th of an inch. I'll make a cut start right here. I'll make a cut. I'll move it back a little bit, make a cut. Keep moving it back a little bit, make a cut. Every time I do that, I take the maximum depth of cut on this side and I gradually taper into it wherever I introduce the saw. And so eventually I'm going to have a taper. Okay. And so that's kind of a nice way to do that. I mean, obviously you could use a skill saw for that too. And there are situations where you use one or the other, but not a super, I guess I don't use it a ton. Sometimes I'll use it like if I've got a rough sawn edge board and I need to straighten that out so I can, and I don't have a joiner available, that might be a good option for that as well. Sometimes boards will have a nasty twist in them, and that's a no-no to rip a board with the twist, and so you can use it for that as well. But again, it's hard to do, and so you know there's different tricks. There are better options for that as well. Okay, so not a super useful tool. You can kind of see how it works right there. That's what a portable hand planer is. Okay. Drilling tools. You've got lots of different types of drilling tools, okay? These have really come a long ways. I remember when I was a kid, they weren't not as common. The battery technology wasn't there yet. But nowadays it's pretty fantastic. And a lot of these little drills you can buy that have hammering technology. You guys know what hammering technology is? You have different settings on these. So this is your drill setting. So there's a little arrow on the top. So you can use them for driving screws, and you can set your torque setting. So if you wanted it to be a real weak tighten, it's a setting that will basically cause the chuck to slip. Okay. If you want to use it for drilling, then you don't want it to slip, you've got that option. And then if you want to do drilling, but you're using a specialized carbide bit and you're drilling into concrete, you can hammer. Okay. And that hammering action is going to, help to break up the cement and the lime and all that, the concrete. Okay. So that's really nice. It used to be that and this is still kind of my preferred tool. If you're doing a lot of hammer drilling, you can buy like a heavier duty hammer drill like this, and you can outfit it. If you've got real big bits and you need a lot of torque in order to turn those, and they're real deep holes, you're going to want to use something big like that. But for little drilling jobs, those little hammers for, like, say for example, setting little Tapcon screws like this, and you're running these little bits, those little battery powered bits are more than sufficient. Okay. There are situations where you need to get into tight corners. You could use something like this. This is called a right angle drill. Okay. And this one's got it's got a keyed chuck. So you can see you got to use a key in order to open and to close the Jacobs chuck around the bits. Okay. And so this is all called a keyed chuck. The one I just showed you is a keyless chuck. Okay. Or a quick grip. And so these are nice because you can fit them in. Let's say, for example, you're drilling holes between studs for running water line or electrical wire. And you have kind of at the end of your wall a really narrow cavity. You can get right in there with a short bit and punch that hole through the 2x4. So those are nice. Sometimes you can use your drill to mix drywall mud, right? You need something that goes a little bit slower, something that has more torque. One of these big dogs. And then to have that extra handle on the end so you don't damage your wrists is pretty important when you're dealing with a lot of torque. And so this is nice because it goes slow, you get high torque, and then doing heavy duty applications like mixing mud or even, I'm trying to think, what are some other applications that you would need that kind of torque for? Mixing paint, maybe not so much. Anybody got any ideas? That's what I use it for. Mixing mud, mixing concrete. Yeah, you could use it for that as too. And so, but otherwise, these little hand drills are good. I didn't bring with me any impact drivers. If you're driving a lot of screws, if you're installing a deck, those little impact drivers are really nice. And so, just got to make sure you have the right kinds of bits for those, because it's easy to break them that way. The battery technology is really pretty good, but again, I always have a corded one in my truck if I need it. Okay, if I run out of battery. But I mean, the battery chargers nowadays are able to do fast charging, and the batteries are lasting longer, and it's getting really good. So the corded ones are being used less and less all the time. But yeah. They do have different sizes of chucks, so just note what you got. And so most of the battery ones now are 1/2 inch, so they do have quite a bit of capacity. So I think we're going to get into some different types of bits. One thing I want you to do is learn the different types of bits and what are they used for. Okay, so I've got several different bits here. Here's my Forstner bits. Forstner bits are a very popular woodworking bit that are used for making very clean, flat-bottomed holes. So Dylan, your guys are going to be, well, I guess yours is going all the way through, isn't it? No? Okay. So then this would be the type of bit that you'd want to use. You're making a blind hole that's 1 inch in diameter, so it's not a small hole, and it needs to be clean. You don't want a lot of chip out around that, around the hole. And so using a Forstner bit is going to be a good way to do that. You've got a brad, so it drills straight. You've got these kind of a sawtooth outside perimeter, so it's going to cut the grains really nice, and so it's going to create a really nice hole. And you can buy these sets, and they'll go all the way from 1/4 of an inch all the way. This one goes up to 2 1/8, and so those are called Forstner bits. Okay. You also have your another popular woodworking bit is called your brad point drill. Again, a lot of these are going to have, they're all, going to have that brad point so that they feed it into the wood. One of the challenges with wood is it's not the density, the hardness of the wood is not uniform, right? You've got grain, and the wood is harder where the growth during the winter time, it's not growing as fast. It's harder, it's more dense. And oftentimes your bits, if you're just using a twist drill, it wants to kind of go to that summertime growth that's softer, right? And so having a brad point is pretty important if you're wanting to drill very straight holes into hardwoods that way that are really hard. Okay, so you've got a brad point, but then oftentimes you also have spurs on the outside that'll help to score and again reduce some of that chip out around the outside. So these are really good. Twist drills, you're going to want to have these around because you're going to need to drill into metal, you're going to need to drill into plastic, and this is really the way to do that. And a lot of times is sufficient for what I need to do. If I'm drilling a pilot hole for a screw, a twist drill is hard to beat that way. Unless you've got one of these fancy combination pilot drill or drill and countersink bits, these are fantastic. I don't know if you can see that, but I bought this one from Rockler for a little bit of money, and this I've been very impressed with this. A lot of these, it's easy to run them too fast, especially when you're running a taper bit, and then they start to get hot and they start changing colors. You don't necessarily want to run these very fast. You want to run them in a slow speed so you don't lose your temper. But these are a really good bit, and it combines. The nice thing is you don't have to do it in 3 different processes, right? You'd have to, if you're doing it using simple or some of the old drill technology, you would drill your pilot hole, and then you would drill your counter bore, and then you would drill your countersink, or and that's really not ideal. So having a bit that does 3 different operations in one is going to save you time that way. These auger bits, generally, when I'm talking about an auger bit, I'm talking about a bit that has a screw feed. Okay, this would be another application where you need a drill that has a slow speed with high torque, because the rate at which these bits are removing material is very fast, and there's a lot of force that's required. And if you're not careful and you're using a high-speed drill, it can hurt your wrists really quick. But I use these a lot if I'm boring holes for plumbing or electrical purposes, running pipe or wire through the wall that way. And so these you guys come up and check out some of the stuff when you're at your leisure after we're done here. Let's see, a couple other bits. So this is a common bit. This is called a spade bit. These are really popular because they're cheap and they can hog out a lot of material really fast. Okay. If you're drilling through countertops, having a spade bit that has these spurs on the outside is good, but Formica, that melamine material, it's really hard on tools, and so you don't really care when you use a spade bit because they're cheap. Okay, and so that's why I like using these on for that purpose. But these will work good, like too, if you're running wiring and you don't have one of those special auger bits, something like this would do the job as well. Just don't hit any nails, because it'll, I mean, and that's the other thing too, is if you do hit a nail, you can just take a file and resharpen that. There's nothing really fancy about, there's not any complex geometry or complex, you don't have to have a diamond grinding tool in order to resharpen one of these bits. And so they're very easy to resharpen and or modify to fit whatever type of hole you want to make. Okay, I've done that before as well. And this is called a VIX bit. It's got a little spring-loaded part that has a bevel on it, so you can actually use it to drill a pilot hole for like a hinge, a screw that's going to attach a hinge. So you take your hardware, you put it in place, and then you take this bit and it'll center itself in that hole that's in the hardware, and it'll drill a perfectly centered hole every time. And they make they make these with different diameter bits. So depending on if you're using an 8 gauge or a 6 gauge screw, you can find the one that you need. And so that's a new one that we've started buying that way too. All right. So here's an application that you might need to do someday. What is this? This is one of those European hinges, and you have to drill basically a large blind hole with a flat bottom. What kind of a bit would you use for that? A Forstner bit. But not just any Forstner bit. You got to have a metric one if you want it to be right. I mean, that's kind of, I don't remember what size it is, but it's some weird metric size. Rockler sells them. We've got a couple. But the other thing too is using a jig to try and help guide that in. You can use portable tools, and if you use a jig to kind of help guide that in square, you don't need to use a drill press. Okay, and so that's really nice, and you get your spacing perfect. Oh, so here's one. So you've got the bottom of a stool, and those need to be drilled at an angle, or you could say a hall tree, and you need to drill at an angle. Could you do that with a portable hand drill? How would you do that? Or what would be the best? Would you want to do that with a portable hand drill? And what kind of a bit would you use? What do you think? I'd probably do it in two different, I'd probably use a Forstner bit, use it and do it in two different operations. Which one do you want to start with? First, the big hole or the little hole?
Big one.
The big one. Why? Because if you drill the little hole first, you got no way to keep your bit centered when you try to drill that big one, because you don't have any material there to guide your brad point, right? So you want to drill the bigger diameter first, then drill the second one. And I'd probably use the drill press. Just take your table and set that up at the angle and use a little V block, and then you can just kind of spin it and get that lined up just how you like it. Oh, boring some holes for some house wiring. What would you use for that? An auger bit, ideally, if you've got one. Okay. A right angle drill is always good. You could get by with a spade bit though. And I suppose if you have I don't know, a lot of wiring is what, about 5/8 inch wide. You could use a 5/8 inch twist drill. You really don't care what it looks like as far as chip out and that sort of thing. So they make 5/8 twist drills. Here's a sink basin drilling through it. That almost looks like solid surface plastic, or maybe it's melamine or Formica. What would you use for that? If it was Formica, definitely a spade bit. If it's that solid surface material, you probably want to use maybe that tends to be a little bit more machinable and not as hard. It works just like wood does. And so I'd probably use a Forstner bit on that. But yeah, I think we're assuming here that, oh, that's HP. Yeah, so high pressure decorative laminate. That'd be Formica. Okay. So, ooh, drilling holes in glass. What would you use to drill or to do that? You said a hole saw? You said what? A diamond coated hole.
I said Forstner.
Oh, you said Forstner bit? Okay, probably not. Diamond is about the only material that you're going to be able to cut glass with. And even with diamond, yeah, you got to keep it cool. You can't shock the glass. You can't, I mean, heat is just your enemy. Ideally, you'd have like one of those little water jet tables. You could use a jet of water with a little bit of abrasive mixed in, but yeah. They have these little carbide tools that are designed for drilling glass. And then this is a fancy hole saw that has the diamond coated, the little diamonds that are glued to the end of it. Or I guess they're not glued, but it's more of a vitrified bond. But then I like this because they just basically took some modeling clay and kind of dammed up a little area and added some water to try and keep it cool. Because that's your enemy when you're drilling glass, because otherwise it'll crack. I haven't had great success with these. I feel like it kind of wedges and creates some nasty pressure and just creates cracks. And so ceramic tile, I'll use these little hole saws. What about drilling round parts, small round parts? This one in particular, we have to drill a center. I had to do this one time. I was making like a toy truck, and I had little 4 wheels, and I needed the axle holes to get drilled, and I needed them to be perfectly in the center. How would you drill that? Andy, I think you probably know. Use the lathe. Yeah, that's what I would do. That would be the best option, right? Just chuck that thing up and use your drill. But you can get creative. So if you're going to use a drill press, you almost have to get your board set up. Basically, take your board, cut a kerf in it, because that's going to be the only way you can clamp onto that round object and keep it from spinning as you're drilling it. And then load up in the drill your 1-inch hole, okay? And then drill the hole that would be the outer diameter, then insert your part in there. And then without moving anything, it's still centered right on the center, you know. But again, wood is one of those materials where you don't have a perfect uniformity. You've got hard spots and soft spots with the grain. And so it's going to want to move if the part is very long. And so lathe is really the best way to do that. There's another example. Okay. What about wooden plugs? How do we make those using drilling tools? Yeah, I guess I omitted that one earlier. There is such a thing called a plug cutter, and that's something that you guys are going to do in class, is use a plug cutter to make a bunch of plugs. So, and that's one that you almost have to do if you're on a drill press, okay? Because you need that to be perfectly perpendicular. You need to be straight in, straight out. Because if there's any wobble at all, then now your plugs are too small and they don't fit tight. And so that's important that you use a drill press with that. Drilling equally spaced holes. You're going to use a jig, or you're going to use a multi-spindle drilling machine, which none of us really have one of those. Otherwise, you can use, this is kind of an interesting thing. You can use a drill press, right? And then set up your fence, and then set up a little jig that will help to align your individual holes. And so I love talking to old timers, because they had to do all these things without the new jigs and stuff that you buy from Rockler. They had to figure it out, and they're very creative. Okay, drilling pilot holes for hardware. Talked about using the VIX bit. And so that's kind of a nice thing. You've got different types of screws, all right? And I think that's something that we don't often think about. How do we prepare a hole for these different types of screws, okay? You have for the Philister head type screw, you're going to need a counterbore hole. For your flush head type screws, you're going to need a countersunk hole, meaning you've got an angled. Now, depending on if you're going to fill it with a plug or if you just want it to be flush, you may or may not need to counterbore that deep. But that might be an option too. But yeah, the other thing too that not many people think about, and at least I had sometimes it's hard to explain. When you're drilling two boards that you want to suck up nice and tight with each other, and you're drilling oak. I think somebody was doing in class the other day where they were trying to drive a screw into oak without drilling a pilot hole. Was that one of you guys? What happened? The head of the screw twisted off and snapped off. And so oak is hard enough that you have to drill a pilot hole first, okay? Let's say, for example, we have two pieces what we're trying to put together. You need the screw to bite into that bottom board. So you're going to drill what's called a pilot hole. So in other words, you're going to take your screw and you're going to find a drill bit that's smaller than the major diameter of that screw, but larger than the wire diameter or the minor diameter of the thread. And so that when you drive that screw in there, you've got material that it's going to bite into, okay? But the top piece, you have to use a larger drill or a clearance drill, a clearance hole, because you need that to be able to spin freely. Because if there's a little bit of a gap between the two boards, you need those to suck up tight. So you need there to be a little bit of, you need there to be clearance on the top part of the board. So that's why these bits are so good, because they use a tapered bit. And so the end of your bit is your clearance hole, or is your pilot hole, excuse me. The top of the bit is sized appropriately to be your clearance hole, and then you have your countersink and counter bore all in one bit. And so it's pretty nice little, whoever invented that was really thinking. Okay, does that make sense? Pilot hole, clearance hole, counter bore, countersink. Okay. Routers. Routers are pretty useful. We've got lots of different ones. You guys, I've got some videos online, and I'll make sure to put them on Moodle if they're not already there. But definitely check this out. I've got one called Router 101 Basics by Steve Ramsey. This is one that I pulled off of YouTube. And but he does a good job of kind of explaining routers and how they're used. But I'll just try to hit the basics that way. But this is, I guess these are not called laminate trimmers anymore. People are starting to call them mini routers. Okay. But when I was growing up, they were called laminate trimmers because that's what they were used for. When you were gluing laminate onto counter subsurface, you would use a flush cutting bit and you would just run and trim up the laminate. You didn't need something that was very heavy duty. Okay. But what happened is people found out that, gosh, these are really nice machines. They're lightweight. I can actually take this to my cabinet that's already been assembled and run it because the base is so small. It's very easy to manipulate. It's just a delight to just for doing light duty roundover applications. This is a fantastic machine. And so it's been used more and more as a router. So now they call them mini routers. This is by far my favorite. But again, these are used for doing light duty routing. Okay. The bases can be adjusted. You adjust the screw to adjust the height of the router. You've got your base, you've got your bit, and your bit fits into the collet, which I don't know if you could see that. But you have a collet down here. You take a wrench, you swivel this while pushing this button, and you can lock that You can lock the shaft, put the wrench on there, break that loose, pull that bit out, replace it with a different one, okay? Just don't ever push that button when you turn on the router. It's you'd think that that would be kind of like duh, but some of these rotary tools like this, especially Dremel tools, they put those buttons in the most convenient places, you know, and when you're just trying to hold it, you accidentally push on those buttons. And if you didn't realize what that was for, it's very easy to make that mistake. And now you have no way of locking your shaft to take that collet off. Okay. The other thing too is look at this collet, or look at the collet, look at the bit. You see how I've got that mounted in there? There's a little bit of space. Okay. And that's really important because, and I'll show it to you guys as well. There's a little bit of space. You can kind of see a little bit, and you can see that there's a little bit of unpainted shaft of that bit exposed. And I try to do that because there's a little fillet at the very top of that bit. And if you push it all the way in, that collet will lock on to the fillet and not the shaft. And so after about a minute, your bit comes loose, it starts moving up, and then your cut gets deeper and deeper. You've ruined your board, and if you're not careful, that could come all the way out of the machine. And now you've got a spinning bit flying all over the place. All right, so in order to put this back together, we got to line that up, click that in, and then lock that base. We're back where we want to be. I really like this little Porter cable. This is, of all of them, Bosch makes one, DeWalt makes one. This little Porter cable is my favorite. So if you're doing a little bit heavier duty routing, you could use, again, I like Porter cable. That's kind of their bread and butter. They do routers really well. Okay, I like these Porter cable routers. I don't even know what size motor this is. Is it a 3/4? Used to be, they always printed them and put them right on the top, but this is a model 1001. That's what they call them nowadays. They don't have a horsepower rating on them anymore. But anyway, this is what we use for doing a lot of dovetailing, just kind of medium duty applications. The nice thing about these is you can put these little template or these bushing guides in the router bases so that you can follow a template, right? You can make templates out of 1/4-inch hardboard, and then you can just kind of follow the edge of your template. And so these little bushing guides are really nice in situations where you don't want to use a bit that has a bearing on it. Okay, you got to have some way to guide your router into the work that way. This is a heavier duty, and this one has an extra feature called a plunge router. And so you have, I want to get into a spot where everybody can see. You have a base. You've got a bit in there. You set your base on your work. You turn it on, and then you plunge down. Oops. I want to push that down, but when I have it, anyway, push that. Plunge down, cut it, run your cut, and then you can return it back up into the top position. Okay. So that's called a plunge router. Got your trigger here. You've got some minute adjustment here. Okay. It's a good tool too. But again, they're heavy, they're big, they're awkward. And unless you've spent significant time using one, sometimes they're hard to use. Okay. They do have two different styles of collets. Well, probably more than two. This is your Porter cable collet. This is your Bosch collet. All right. So they do have different types of collets depending on the model or the brand of the router. So just make sure that you note that. Okay. So that's kind of a little bit about routers. I think we went through all this. Oh, as you're routing things, So the router turns a certain direction. Which way do you feed? Do you feed with the rotation or do you feed against the rotation? Against, that's right. You don't want, when you're running the router, you want to push up against that rotation cutter or that cutter rotation, and that's going to give you better control. Okay. The other thing too is we were talking a little bit about this, is if you're cutting a board like this, let's say I wanted to round this over, does it matter which side I do, end grain or edge grain first? It does. What'll happen is when you do that end grain, what'll happen, that router bit will cause the very end to chip out, okay? Because there's nothing there to support it, okay? And so if you do the end first, it's going to chip out, then you do the edge, and you've just removed that material. You don't see that it was even an issue. However, if you did it the other way, so you did the edge first, and then you did the end, well, it's going to chip out on the end, and now you've got this little bit of chipped out grain on the end. So, and nothing to remove, right? And so it does matter. Make sure that you always route the end grain first and then the edge grain, okay? Some of these routers will have variable speed, so you can kind of, you can adjust that. But with woodworking, I guess one thing I found is you just run it fast. You use carbide tooling and you don't have to worry about overheating the cutter, okay? In fact, I found that I always run these things full out, and usually when these routers go bad, it's the variable speed control that goes bad first. And so if I can, I always try to buy the fixed speed if I'm using them for wood, right? Because you really have no need to change your feed rate that way. But it seems like anymore, that's all you can buy is variable speed. So hopefully they get that figured out. Yeah, so there it is. This is a picture that shows what happens if you route the edge first and then the end. You get that little bit of tear out, okay? So you always want to do the end grain first, okay? I guess with regards to feed rate, if you go too slow, you get a lot of burning, okay? If you go too fast, you get a lot of tear out. So you kind of have to find that happy place, okay? And so just be aware, if you're getting burning, go faster, okay? I think that's something that maybe people don't realize. Deep cuts, try to take it easy, okay? Do it in multiple passes, all right? Rather than making one deep cut, make a couple of shallower cuts, so that you get a good quality cut, but then you also don't overwork your router so that you don't burn up the motor that way. If you're doing circles, you can use circle cutting jigs. Okay, those are really helpful. I've made those just using a piece of aluminum bar or flat stock. And so that's, it's easy to kind of get, you can make those out of wood too. A little piece of 1/4-inch plywood, you could drill a couple holes, screw it up to the base, and you're ready to rock and roll. And so, and then if you've got straight dados or rabbets that you need to do, you can use a fence. Okay, I've done that a lot, where a lot of these routers will have a flat edge on the base, and you just run that along the fence. And so that's kind of a nice feature that way. Okay, you can use different types of jigs and templates for doing sign making. I talked a little bit about these little guide bushings. Here you can see a person using this is what would be a laminate trimmer. You're using a trim style bit that has a bushing or a little roller bearing on the top. You're just running along this template, and that's what you're using to cut that part so that it's perfect. And then you can take the template and move it to another part, and you can get duplicate parts that way by using templates. Okay. Here's another video I'll post on Moodle that shows how to use a router and a dovetail jig, and so that'll be there on Moodle for you. There it is again. This is I have one of these Porter cable routers that has a dovetail bit installed in it. That's all I ever use it for, and so I keep it in my cabinet hidden away so that dovetail doesn't accidentally get moved. Okay, because trying to get your dovetail, the bit, the joint to fit just right is a matter of how much your dovetail bit sticks below the base. And so we try to, and the other, it's also a matter of the thickness of the material. And so as long as you are, we try to only dovetail drawers that have 1/2 inch thick drawers, thickness. And so then we can kind of maintain and keep a standard setup on our router jig that way. We also have a CNC router in the lab, and so we use that has a little laminate trimmer hooked up to it, and so we use that to do a lot of carving. And so if you're interested in incorporating something like that into your heirloom project, we can certainly do that. And then finally, we've got some portable sanders. The portable belt sander, great machine, trying to remove a lot of material. Keep it, make sure when you turn it on that the belt tracks, okay, because these belts can cut right through the housing, and now you've just got a nice boat anchor, okay, if it's a good one. The good ones are heavy, right? But yeah, outfit with a real coarse blade, you can remove a lot of material really fast, and so it's just a matter of moving it back and forth, left and right as you go. I would refer you to the demonstration on sanders to see how that works, because I do show in that video how those work that way. But it's a great tool that way. Okay, for most of my sanding, I use these random orbital sanders. Outfit with a nice sharp 80 grit sanding disc. You can remove a lot of material really good, really fast. Just keep that tipped up on edge, so you're using kind of this one side, and you can use a systematic approach. You can do a very good job and sand real, relatively large surfaces, very flat and smooth, and used for a lot for finish preparation that way. Okay. There are two different general styles. So this one is, got an adhesive back. The other style is what's called a hook and loop. I don't think I have any examples of that. That's what I use at home. Most hobbyists will use a hook and loop, which basically it feels like Velcro. It just works like Velcro. You take your sanding pad and you stick it to the bottom of your base, which kind of has that Velcro, and it sticks. So those are the two different types. So when you're buying sanding discs, you have to make sure you have the right diameter. Some of these are going to have holes for dust collection purposes. Others do not, like this one. And so they make sanding discs that have holes or without holes. And so that's, I guess, something to remember. You can use those oscillating tools for sanding, or they also have these little specialized sanders that are designed to get into the corners. That's one of the challenges. These little guys right here are pretty much worthless. I think every high school shop has them because that's the cheaper option, but they really are pretty ineffective when head to head with a random orbital sander. And so that's what I learned how to sand with in my high school program. I hope that they have replaced those with the newer technology, because otherwise it's a waste of time, and you start teaching students not to like sanding, because it's a horrible experience. Anyway, it works good for pine, real soft woods, but for like oak, you need something that's a little bit more aggressive. What I use these for a lot is if I have a table, a large surface, and I've just sprayed it, and with the first coat of lacquer or polyurethane, and I want to sand off all the bumps and the high spots, I'll use this to sand in between coats. But again, that only works for larger surfaces. Otherwise, it's just faster just to take a sanding block and just hit it with by hand. Plate joining, that's another one. I think we've already kind of talked about that. And that's it. Hey, we made it through another one. All right, so please read through chapter 4. Make sure you define the key terms, and make sure you work through the chapter questions as you prepare for next week's quiz that way, okay? We will have a quiz over this next week. Let me know if you have questions. Otherwise, there's a lot of really good stuff in here with regards to portable power tools. And so much of it is just knowing what the right tool for the job is. So check that out. There's a lot of really good stuff there. So thank you.